Okay, we're in Core 3, differentiation. Remember that not every time do you have to use fancy rules like the chain rule, product rule and quotient rule and so on. This is just using the basic rules for differentiating e's and, in this case, 12x. We've got to find dy by dx and then differentiate again to get d2y by dx squared. Should be 3 fairly straightforward marks. Then in part B, this is about stationary points on the same curve. So the first thing we've got to do is show that the x-coordinates satisfy this equation. So the starting point for stationary points, you write down your standard starting point. It's to do with dy by dx. Say what dy by dx has to equal. Set up that equation and you should be able to rearrange it into this form. Of course, if you get stuck, that doesn't matter all that much because we've got a re-entry point right here. Even if you couldn't get this equation, we can solve it. Z equals e to the x. So we've got a term that easily turns into z's there, and the slightly trickier one is that you need to write e to the 2x. In terms of z, you need to use rules of powers. If you remember that x to the power of pq means x to the power of p to the power of q, then that might help you think what e to the 2x is expressed in terms of e to the x. Once you've got these replaced by z's, it will turn into an easy quadratic equation which you solve for z, get two values of z, and once you've got each value of z, remember that z equals e to the x, so you should be able to solve it to get these two given x values. Once again, if you couldn't do that, we have yet another re-entry point. We know the x-coordinates of p and q. Now all we've got to do is find the y-coordinates of p and q. How do we find y? We've got an equation for y up here. So we need to substitute the given values using exact methods into that equation. You do need to be a little bit careful about showing you're working for this term here. When you're substituting a log into that, we know we're going to be substituting log 2. When you're substituting log 2 into e to the 2 log 2, your calculator will tell you the answer, but you may not get full marks just by going straight from that to what it equals. What they really want to see is that written as e to the power of log something else. Use the law of logs to write it as e to the power of log, and then of course an e and a log will cancel each other, so you'll get down to a plain number at the end. So put this step in so you're convincing. And then finally, using the answer to A part 2, determine the nature of each stationary point. We've got to use a second derivative. You remember your core 1 recipes for how to find out whether it's a maximum or a minimum, depending on whether that's positive or negative. It's not going to be 0 because then you can't tell. Here are the x values. Substitute them into your d2y by dx squared. Get an answer that you can recognise as positive or negative. Say so convincingly and draw your conclusions, and that should get you the last 3 marks.